Today we're going to talk about composition of functions. The composition of functions, f with g, is denoted by the notation f open circle of g close parentheses of x. Okay, so this is red, f of g of x. I know it looks like fog. The first time that I saw this in my textbooks, I was wondering why fog was in my textbook. But this little circle is smaller, like you can see down here in our definitions. But you need to make sure that it is open because a closed circle means something different. So if it is filled in, if it looks something like that, that is something completely different than an open circle. What this means, so fog, what fog means, f of g, means that we take our g function and we plug it into our f function. Okay, so our g function gets back substituted into f. Notice f's on the outside in fog, or f composed with g, so it stays on the outside when we're looking for plugging stuff in. If we have golf, G composed with F, it goes the other way. The G's on the outside, so the G stays on the outside. And instead of G of X, we're going to have G of F of X. So we plug in F into G. We're going to be color coding a lot, so if you like colors, bust out your colors. They may help you. Now, the domains of compositions can get really tricky because we've seen that rational functions have restricted values, the denominators. We've seen that polynomials are just game for anything, negative infinity, positive infinity. But then we've seen what happens when we have radical functions and how that depends on the index. So I can't give you straightforward rules on how to find your domain for f composed with g, not like with the rationals where we set it equal to 0. Instead, we have two rules for excluding values. And this is for f composed with g, which means we're plugging g into f. If x is not in the domain of g of x, so if it's not in the first part, then it can't be in the domain of the composition. And since we're plugging g of x into our function f, if we have an x value that makes g of x not in the domain of f, we got to throw that guy to the curb too. We can't include him if he makes anything undefined. Our first couple examples, we're going to start with our friends. If you don't know why I'm saying they're our friends yet, you'll see here in a moment. And we're going to get just the concept of plugging these functions in. Okay, I am going to color code. So I'm going to say f of x is my purple function. And I will make my g of x orange. Okay. These guys are our friends because they are both polynomials. Polynomials are our friends. They are so easygoing about their domain. Okay. All right, let's find f composed with g. And again, I'm going to do some color coding. So f composed with g, or fog, means that we are going to have f of x, but instead of f of x, I'm going to erase it because we're going to plug some stuff in, is equal to 3, instead of x, we're going to have something that we plug in, minus 4. My minus 4 stays the same because he didn't have an x on him. But here, we need to plug g into our f function. So instead of f of x, we're going to have f of g of x. And remember, g of x was x squared minus 5x minus 10. So I could also write this as f of x squared minus 5x minus 10. But what that means is that we are going to plug our x squared minus 5x minus 10 anytime we see an x, which I have 3x. I left open parentheses set here, which means we're going to substitute in our g function. So you may see this written one of two ways. You could see it the first way, this first line, or you could see it the second way, where I have f of the polynomial instead of f of x. But notice that this means the same thing. We are plugging g of x into our f function. So wherever we see an x, we're plugging in our g function. We're not done yet. We need to simplify. To simplify this guy, we need to distribute our 3. And remember that 3 needs to go all the way through. Okay. So 3 times x squared gets us 3x squared. 3 times negative 5x gets us negative 15x. 3 times negative 10 gets us negative 30. And we bring down our minus 4. Combine our like terms. We get 3x squared minus 15x minus 34. We just found f composed with g of x. That guy is our final answer. Now we need to look at the domains. Both of our original functions, f and g, are polynomials. Since we plug g into f, we're going to start with looking at g. The domain of g is all real numbers, negative infinity and positive infinity, because he's a polynomial. That means no restrictions. Since g is not bringing any restrictions to the party, that was our first step. We're now going to look at our composite function. So step 2, does f composed with g have restrictions? Okay, so if we look at f composed with g, we did not have a denominator at any point. We did not have a radical at any point. So that means that f composed with g is a polynomial, which again means no restrictions. And if that's the case, we have no restrictions from g, we have no restrictions from f of g, that means that we have our combined domain with no restrictions. And if we have no restrictions, that means our domain is negative infinity to positive infinity. Polynomials are awesome. They are your best friends because they don't have issues with their domain. Remember, it's all real numbers, negative infinity and positive infinity. I'm going to write my functions out again, just so we're not losing sight of them. We have f of x equal to 3x minus 4. I'm going to keep that purple. And then our g of x was our trinomial, the x squared minus 5x minus 10. This time, instead of asking for f composed with g, it's asking us for g composed with f. So we're going to be plugging f into g. We said g of x, our orange function, was equal to x squared minus 5x minus 10. But remember, if we're plugging in g composed with f of x, that means that we are going to have g, and we're going to plug in f of x. So instead of g of x, whenever we have x squared, we're going to have f of x squared. Minus, instead of 5x, we're going to have 5 of f of x. And instead of minus 10, what do you mean instead of, right? The minus 10 stays the same. If this point we were in the classroom together, I would ask you why, but since I can't do that, I'll just tell you that negative 10 doesn't have an x, so we can't do anything with him. Now let's plug in. We said that f of x was equal to 3x minus 4. So instead of f of x squared, we will have 3x minus 4 squared minus 5 instead of f of x. Again, plugging in for f of x, 3x minus 4 minus 10. Please do not tell me 3x minus 4 quantity squared is 9x squared plus 16. That's not how it works. Remember, when something is squared, you need to multiply it by itself. So 3x minus 4 quantity squared is 3x minus 4 times 3x minus 4. We get 9x squared minus 12x, because we're taking first, outer, so the 3x times negative 4. Inner, negative 4 times negative 4 times 3x gets us negative 12x. And then our last is positive 16, because negative 4 times negative 4. We need to distribute the 5 through our parentheses. And since he's negative, we're going to multiply by negative 5. Negative 5 times 3x gets us negative 15x. Negative 5 times negative 4 gets us plus 20. And don't forget our minus 10. If you forget our minus 10, you're going to get the problem incorrect. So don't forget it. Once we're here, we're almost done. We need to combine like terms. There's only one x squared term, so 9x squared. If we combine our x's, negative 12 is negative 24. So you owe me $24, you owe me another 15, means that you owe me, so negative 39x. And then we have 16 plus 20 minus 10 gets us plus 26. And this is g composed with f of x. I'm going to scroll up just a little bit. You can see that they are not the same answer. We're going to have specific cases where we get the same answer, but that's in a later section. Okay? And if you notice, g composed with f of x is also a polynomial, which means that he has no restrictions, because he did not have any denominators at any point in his work. So our final part has no restrictions. The function we were plugging in, f of x, so I'm going backwards, sorry, that was step 2. F of x has no restrictions on the domain? And that is because he is a polynomial. Then we're saying that our composition has no restrictions, which means that the domain of our composition, so G composed with f of x, and remember that that circle better be open. Since we have no restrictions either way, it's going to be negative infinity to positive infinity. I'm highlighting my answers since I didn't really give myself enough room to work on this page. There we go. Notice when they ask us to find f of g of x or g of f of x, we get our answers, what I have highlighted in green, with an x in them. We wound up with another polynomial. In our next example, notice that they gave us, instead of an x, they gave us a -2. I'm going to write down my function again. So g of x equal to x squared minus 5x minus 10. They're asking us to find g composed with g of -2. I know, sounds absolutely bizarre, but sometimes happens. Okay. So this -2 is going to get plugged into g. And then g is going to get plugged into itself. I know this sounds super weird, just bear with me. Here they are asking us to find g of -2. Okay. So we can find g of -2. We've done this multiple times before. Instead of x squared, we're going to have -2 squared. Minus 5, instead of times x, we'll have times -2. Minus 10. We need to work out the arithmetic. Make sure that you're putting the parentheses around your numbers when you plug it into the calculator. You can plug this entire thing into your calculator at once if you would like. You're not required to. But 2 squared gets us 4 plus 10, because -5 times -2, minus 10, which gets us 4. So we've said the entire g of -2 is equal to 4. If I bring down my g on my outside, I'm asked to find g of -2, by definition for g composed with g of -2. But we just said that g of -2 is actually 4, which means I now need to find g of 4. Which means instead of x squared, I'm going to have 4 squared. Minus 5, instead of 5x, I'm going to have 5 times 4 minus 10. Do the arithmetic. 4 squared is 16 minus 20 minus 10. We wind up getting -14. And that is our answer. Okay. G composed with g of -2 actually gets us -14. The only answer that you would need to put into your homework would be -14. And that's because they gave us the -2. They gave us a number. When they give us a number, we give them a number back. When they give us an x, we give them an x back. Let's try another one. We're asked to find f composed with g of x and its domain. So this time, oops, Let me bring that back out just a little bit. So this time I'm going to make my f of x equal to 2x squared plus 11. I'm going to make that in blue. And I'll make my g of x equal to the square root of 4 minus x. I'll make that in orange. So when we are asked to find f composed with g of x, that means that I am going to take my g function and plug it into f. The other notation you may see is f of g of x. Okay. But remember that g of x is equal to the square root of 4 minus x, which means in my original function, when I had 2x squared plus 11, instead of x squared, I'm going to put in my square root of 4 minus x and include my plus 11. Much like the 10 in the last problem, the 11 doesn't get anybody with him because he doesn't have an x. And I forgot my notation. Sorry, I forgot there is a square on that exponent. So 2 times parenthesis, square root of 4 minus x, close parenthesis, squared plus 11. Now you may remember that when we have the square root of something and we square it, the square root and the square, oops, wrong one. The square root and the square take each other out. Okay. Which means that we are working now with 2 times parentheses, 4 minus x, close parentheses. The square and the square root are gone because they canceled each other out, plus 11 still along for the ride. Remember, we need to distribute 2 times 4, 2 times negative x, which means that we have 8 minus 2x plus 11. And if we simplify by combining our like terms, we find f composed with g of x is equal to negative 2x plus 19. You could have 19 minus 2x, that's fine. This is just preference for me that I always put in descending order. So we have f composed with g of x. We need to find the domain. So let's start with the domain for g, because that's where we plugged in first. So g of x, he is a radical function, and his index is 2. Remember that little number on the radical, if it's not there, it's a 2. And here, since it's even, that means that we need to take the radicand, what's under the radical, set it greater than or equal to 0, and solve. When we do this, we would get negative x greater than or equal to negative 4, because we subtract the 4 from both sides to move it over. And we're not done yet because the x is not by itself. You would need to divide both sides by negative 1. But remember, whenever you multiply or divide by a negative, we need to flip our sign. So we get x is less than or equal to 4. Again, this is our domain of g. After we find the domain of g, we can look at the domain of f composed with g. Okay. We know the end result is a polynomial, but we look back through our work. Did we have any denominators that weren't accounted for? Did we have any new radicals that we have not already found the domain for? And since we already have all that information accounted for, we've already found the domain of the radical. We didn't have any new radicals in our work. We didn't have any new denominators in our work. Our new guy has no new restrictions. But we still have the old restrictions. The x less than or equal to 4 is still in play. Okay, so x less than or equal to -4 are our restrictions. It's like the baggage that you bring into a relationship with you. Just because you're in a new relationship doesn't mean your baggage goes away. G got into the relationship with F. His baggage doesn't go away. He still says x has to be less than or equal to 4. And F of G, when F is okay with it, he's like, okay, but I have no restrictions for us to use. So x less than or equal to 4. Remember, you can always do a little number line. We would be shading to the left because we're going less. And the less than or equal to means closed bracket. And we find out our domain is negative infinity with a parenthesis, always, on up to 4 with a bracket.